So today we're doing a lesson that is a little bit of 12-3. We did 12-3 already, but there's a little bit more, and one part of 12-4. So I call this 12-3/12-4, and we're talking about tangents and secants. Okay, so some of you already did a couple lessons on tangents one lesson 12-1 was on tangents, and some of you I don't do that lesson with. So I'm going to define tangent of a circle and point of tangency. So if you are in a class that already did these first two on the tip chart, then you can just fast forward through these definitions because you already have that on your tip chart. All right, so a tangent is a line. It's a line that intersects a circle in exactly 1 point. In exactly 1 point. Okay, so think about that. If a line is intersecting a circle, but it's only intersecting it at 1 point. All right, so what that means is this line can't be passing through the circle, because if it was passing through the circle, there would be an entry point and an exit point of that line going into that circle. So it's not going into the circle. It's just touching the circle at just one singular point. Okay, so here's a circle. And I'm going to take a line, and I'm going to just graze the circle with the line. It's just going to brush up against the circle. So like that. That line is called a tangent. Now, that word tangent is the same as the word tangent in the trig ratios in chapter 8, sine, cosine, and tangent. And those two things are related out there in the wonderful world of calculus. But for our purposes, it's going to seem like they're just completely different things. So in this context, a tangent is a line that's grazing a circle, that's just touching it at one single point. And now, since it's a line, you can name it with a lowercase cursive letter, like line L, or you can pick any other point on this line. And remember, there's infinitely many, so we can just pick another one, and we can call it line AB. So you could say line AB is tangent to the circle, or you could say line L is tangent to the circle. All right, that point where the tangent line is grazing the circle, that point of intersection is called the point of tangency. So this definition kind of goes with this one. So the point of tangency is the point of intersection of the tangent line and the circle. And the circle. So in this drawing, point B is the point of tangency. Now, if you don't want to draw that again, you can just put a little arrow and say point B is the point of tangency, or you can draw another one if you want to in this box. So I think I'll put the tangent line going beside it like this. And the point where they intersect, that is called the point of tangency. Okay, we defined inscribed angle and intercepted arc when we did lesson 12-3, and so you should already have those definitions from the last lesson. And now we're going to define secant. Okay, so the word tangent and the word secant, they kind of go together. A secant is also a line. Now, the reason I didn't put of a circle like I did here is because this is the first time we've talked about a secant. I may have mentioned it in that right triangle chapter, because there's something called a secant and a cosecant and a cotangent. So I may have just mentioned it or given some homework, but I don't think we spent very much time on it, if any. So here's what a secant is. A secant is also a line, and it is a line that intersects a circle. So that's what I mean by they kind of go together. They're related, tangent and secant. It's a line that intersects a circle in 2 points. In exactly 2 points. So that means that the line is going through the circle because it's got 2 points of intersection, an entrance point and an exit point. You could look at it like that. Okay, so here's a circle. And I'm gonna draw a line through the circle like that. And see, it's got 2 points of intersection. Now, secants contain chords because secants will always be passing through the circle. So you have this chord right here. And I'm gonna name the secant. Now you could name it with a cursive letter, a lowercase cursive letter written near one of the arrows of the line. But since it's got 2 points of intersection, you might as well name it with those points of intersection. So line AB is a secant. Now the reason I'm writing that is because there is segment AB, which is not a secant, it's a chord, and there's arc AB. So that symbol, when you name secant, is very, very, very important. It's important when you name a tangent also. Symbols are important in geometry anyway, so that you know what you're talking about, but especially when you could use those same 2 letters to name other things. Okay, that is very likely all we're gonna do on the chapter 12 tip chart. So most of you had these, well, not most of you, some of you had that already. We all did this in lesson 12.3, and then some of you did these 3 today. So you should have these 5 done today. Okay, I feel like I went a little too fast. Maybe I moved that too fast. Oh, I forgot. Y'all can pause this and go back. What am I saying? Okay, so now we're gonna talk about tangents and secants. So we had to know what they were so that we could talk about what is happening with these things today. All right, so basically when tangents and secants intersect, you get angles. So I drew you some pictures of just some tangents and secants intersecting. You could probably come across a problem one day where they ask you, like, what kind of lines are these? Are they secants or tangents? But that's really not going to be the focus for us. For us, the focus is going to be finding these angles that are formed. But just in case you were wondering, these are both secants because that crosses at 2 places and that crosses at 2 places. This is a tangent line crossing a secant line. And this is 2 secant lines again. Anytime the line's going through the circle, like into the circle and out of the circle, that's a secant. And anytime it's just grazing it, this one's a tangent crossing a secant. The only one I didn't picture here, you could have 2 tangents. So pretend that's a pretty circle. I guess I could grab my circle maker. And you could have a tangent, and they cross. So yeah, basically, these things are crossing and we're getting these angles. And so I'm gonna move that out of my way just in case I need that space. And yeah, we're gonna be finding the angles of where these things cross. Okay, there are basically 3 scenarios. They either cross on the circle, or they cross inside the circle, or they cross outside of the circle. So these 2 secants are crossing on the circle. This secant and this tangent are crossing on the circle. These 2 secants are crossing inside the circle. This tangent and this secant is crossing outside the circle. And in that picture I drew a minute ago, anytime you have 2 tangents, they would have to be crossing outside the circle because tangents don't go inside the circle. So, so there's three scenarios. Either they cross on the circle, like these 2, they cross inside the circle, like this one, or they cross outside the circle, like that one. Now, the way I wrote it here is that's where the vertex is. So the vertex of these angles that are formed is either on the circle like these. Here's the vertex of these angles that are formed inside the circle. Here's the vertex of these angles that are formed outside the circle. All right, and here are the rules. If the vertex is on the circle, we talked about this in lesson 7.3. The angle is half the arc. So we talked about it when we had inscribed angles like this. The vertex of that angle, that inscribed angle, is on the circle. So the angle is half the arc. And that was lesson 7.3. But there's a little extension of that we didn't talk about, And that's if these lines cross on the circle, but it's not an inscribed angle. So the part of 7-3 we've already talked about is when we had an inscribed angle like this, but it's possible they cross on the circle, but that's not an inscribed angle. Well, the rule is the same. That angle right there, this angle, is half of this arc. And this angle right here, over here, is half of this arc. So the rule is the same. The angle is half the arc. So when the vertex is on the circle, angle half arc. Okay, when they cross inside the circle, you actually get two arcs. Okay, and the rule is the angle is half the sum of the two arcs. So let me explain. So look at this picture right here. They are crossing inside the circle. Suppose I want to find that angle. So suppose that's my missing angle. Well, this angle right here, or this arc is inside that angle, right? But because the angle's inside the circle, the vertex is inside the circle, we actually have some partner angles here. And they are the vertical angles like we learned about way back in chapter 1. So these are vertical angles. They're both x. So since those are vertical angles, same angle, these we can kind of look at them like they're partner arcs. So this arc is partners with this arc. Now that's a little bit hard to understand, so let me just explain real quick. See, the temptation is to think that they're the same arc, but look. I'm gonna make two lines cross inside the circle like this. Okay, I've got myself two secants. They are crossing inside the circle, right? Well, if I wanted to find this angle, that angle has a vertical angle. Those are the same angle. But the arcs are not the same. Look at their arcs. This arc is kind of, you can think of it as like partners with this arc, but they're not the same measure. They would be if that was the center. So let me show you a picture of that. So if they were crossing at the center, like this, the angles are still vertical angles, just like they are here, x and x. But since it's a central angle, remember the arc would be the same as the angle? So those would also be x. All of those would be the same measure. So even these. But if we take that point of intersection and move it away from the center, like we have here, these arcs go together, but they're not the same arc. They have a part in forming that angle though, okay? So the rule is that when the two lines are crossing inside the circle, the angle that is missing is half the sum of those two partner arcs. So if I want this angle right there, I would add the arc that's inside it plus its partner arc. I would add those together and half it. So the angle is half the sum. Now that may seem a little hazy right now, but when we get to practice it, it'll be a little better. And if you want a little picture, that might help. So if I'm looking for this angle right here, I would be using this arc and this arc. If I'm looking for this angle right here, I would be using this arc and this arc. They're like partners. Okay, and then the last scenario is when these lines are crossing outside the circle. All right, so see on this one, they're crossing on the outside of the circle. Well, if you look inside that angle, so suppose this is our missing angle that we're trying to find. There are two arcs there. There's the arc between this point and this point, so that arc. And then there's the arc between this point and this point, this arc. So in this scenario, when the vertex is outside the circle, that angle's half the difference of those two arcs. So you're going to subtract them and half it. So I'll show you another picture like that when they're crossing outside the circle. So here's a secant, here's a secant. They're crossing outside the circle. That vertex is outside the circle. See, when we're looking for this angle right here, there's actually two arcs inside that angle. There would be this one and this one. So we would subtract and half. All right, so here's what I memorized when I learned this a long time ago from Miss Lorene. I memorized on the circle, half the arc, in the circle, half the sum, outside the circle, half the difference. So on the circle, half the arc, in the circle, half the sum, outside the circle, half the difference. Okay, so I am going to use those rules and I'm going to write them down when I do the problems so that I don't forget what rule I am using. All right, so the first thing you do is you find out where the vertex of this angle is that you're looking for. So I'm looking for that angle right there. That would be this angle. Now, that angle does not stop at the circle. It's that angle formed by the two lines, right? And its vertex is right there, which is on the circle. So the rule is, when the vertex is on the circle, the angle is half the arc. Okay, so let me erase this so we can talk. All right, we're looking for that angle right there. And here's the arc that I need. I need the arc that's inside the angle that I'm talking about. So the bad news is they gave me this one. If the whole circle, though, is 360 degrees, and this part of the circle is 100, this part of the circle must be 260 degrees. And now I've got everything I need to be able to find that angle. The angle's x, is means equals, half, and the arc is 260. So that angle right there is half of this arc, which is 130 degrees. Now, there is another way to get that one. Since they gave me this arc, I can half it to get this angle, which would be 50, because the angle is half the arc. And then you can use the 180 thing to get that this one is 130. So that's just another way to do it. All right, I always write the rule because there are 3 different rules, so sometimes it gets confusing. All right, example 2. So here's the angle I want. There's the vertex of that angle, and that vertex of those two lines crossing is inside the circle. And whenever the vertex is in the circle, the angle is half the sum of the two arcs. So I just write angle is half the sum. All right, if it's this angle, then this is one of the arcs, and then its partner arc, which is over here, formed by the vertical angle, which would be right there. Those two arcs are partners in forming these angles. So the angle is half the sum of those two arcs, which is 20 plus 132. So that's what it looks like when you plug everything into the rule, and you get x is half of 152, and that half of 152 is 76. So that angle right there is 76. So is that angle. Because if I was going to find this angle, I would use 20 and its partner, which is the same two arcs. All right, example 3. So they are crossing. I'm looking for that angle right there. And the vertex of that angle that I'm looking for is here, and that is outside the circle. So whenever they cross outside the circle, the angle is half the difference. So that's the rule. I'm looking for x, so x is half. Now, I need 2 arcs here. I need the 2 arcs that are inside that angle. So that would be this one, which they have said is 80 degrees. And then this one right here, this one's missing right now, but I can find it because the whole circle is 360, and this part is 90, and this part is 180. So together that's 170. And if you take the circle and take out the two arcs that I know, 170, that leaves 190. Let me make sure I'm right. 290, 360, yep. So this is 190. Now remember, when I did that subtraction, that's not the difference here that I'm talking about. That's just finding this missing arc using the whole 360. Okay, now I can find the difference of the two arcs. See, those are the two arcs that are inside my angle. So 190 minus 80. And you will not get negative angle measures, so make sure you do the bigger arc minus the smaller arc. Or it'll be the further arc minus the closer arc, because the more inside the angle you get, the smaller the arc is. So half of 110, that is a 55-degree angle. So that's what X is. All right, we're done with that one. Okay, the next two problems are just problems where they've given you the angle instead of asking you for the angle. So things get a little backwards, but the rules are the same. So here are two secants, and that's where they're crossing. They're crossing inside the circle. So this is an n problem. So you write the rule. The angle is half the sum of the two arcs. And then if you look at what they gave us, see, this 40 goes with this angle. And the reason I know that is because this x isn't just floating out there somewhere. That x must be going to that arc. So this 40 must be this angle, and the 78 is that arc. So plugging all that stuff in, the angle's 40. And it's half of the sum of these two arcs, because inside that 40-degree angle is this arc, and its partner arc is over here. So x plus 78. Now you can distribute that half if you want to, but if I'm trying to get x by itself, I don't like to put things with the x. So to get rid of the half, I just double it, and you got to double both sides. So to get rid of this half, I double it, and you double the other side, and you have 80 equals, see, that's going to cancel, 2 times a half. Half of 2 is 1. So basically it's just 1 times x plus 78. Okay, let me explain to you guys what this means. And because some of you will do it this way. If the angle's 40 and the angle's half the sum, that means the sum must be 80 for the angle to be half of that, right? So some people just, instead of writing this algebra, they kind of think through it like that. They go, okay, if the angle's half the sum and it's 40, then the sum must be 80 for 40 to be half of it. And so that's what we found out. We found out that this sum must be 80. And anyway, solving it algebraically, you subtract 78 and you get x is 2. My picture's not to scale, obviously. That would be a tiny, tiny little arc, 2 degrees. Okay, but think about this. It makes sense in the rule, because the rule is that the angle, 40, is half of this sum, and 2 plus 78 is 80, and half of that is 40, so it worked. Okay, last one. Those two lines are secants. They are crossing outside the circle. That's where the vertex is, on the outside, and so the rule is the angle is half the difference. And again, they gave me the angle already. So see, this is one of those backwards kind of problems. Now, before I show you how I do it algebraically, again, some people just like to think their way through it, and so let me talk you through that. If the angle is half of the difference, and the angle's 50, the difference must be 100, right? Because half of that difference is 50. And if the difference is 100, and we've got a 160 and an x, and the difference of them is 100, well, this must be 60. So x is 60. And some people just like to think through the rule like that, and that's fine, but I'm not real good at that. So, because sometimes my thoughts get lost. All right, so I like the rule. And so the angle 50 is half of the difference between the two arcs. So it's this arc and this arc. Now you want to do the big one minus the small one, okay? big arc minus small arc. If you want to, you can distribute the half, but like I said, if I want x by itself, I don't like to put things with the x. So to get rid of multiplying by a half, I multiply by 2. You're multiplying by the reciprocal of 1/2. And you have 100 over here. 2 times a half is 1. 1 times this stuff in parentheses is this stuff in parentheses. 160 minus x. And then we're trying to get x by itself, so we need to get rid of this positive 160. Subtract 160. You get negative 60 equals negative x. If negative x is negative 60, then positive x is positive 60. Or you may like to show that work dividing by negative 1. You get 60 equals x. So that arc would have to be 60 because 160 minus 60 is 100, and half of that difference, half of that 100 is the angle, 50. So it works. All right, that is the rules for when tangents and secants cross. Okay, so that is all there is to that, and y'all have a wonderful day. Bye.